Hi students, my dear students, welcome to this video session. I remain your favorite instructor, Samuel Chukwu Emeka, aka Sam Done for Peace. In this video session, we shall discuss the study guide for quiz 3, and this is part 1. We still have more questions in this part 1. We will try to get it, in at least 2 videos as possible. Okay, so please, it is recommended that you have viewed the videos on these topics and that you have done your homework on them. It is highly recommended so that you can have a better understanding of the questions and the solutions. As usual, anything called equation, I encourage my students to check their work. So the first one is an exponential equation. We have 5 raised to power x is 1 over 25. So you could have that 5 raised to power x is, you want to make this, you want to put this to be in base 5. That is what you want to do. So this is 25 raised to power negative 1. We now have that 5 raised to power x is 5 squared raised to power negative 1, because 25 is 5 squared. So you have that 5 raised to power x is 5 from the law of exponents. From the law of exponents, 2 times negative 1 is negative 2. And then they have the same base, so you can equate the exponents. X is equal to negative 2. And that's your answer. Do you stop here? No. You've got to do what? Check. So when we check our work, we write the main problem first. 5 raised to power x is 1 over 25. And this is our left hand side, and this is our right hand side. Left hand side, you have 5 raised to power x. Right hand side, 1 over 25. Now our x was what? Negative 2. So this will be 5 exponent negative 2. From law of exponents, this is 1 over 5 squared, which is what? 1 over 25. So 1 over 25 on your left, 1 over 25 on your right. You can drink some water. Not soda, water. Water. Okay, so we're done with question 1. Question 2, we have log base 5, 2x minus 8 equal to 4. So what does this mean? You convert this logarithm to, you can do this 2 ways actually. You can do it 2 ways. I'll show you the 2 ways, and whichever one you prefer, that's fine. The first method, first way, you can do this by definition. Okay, you can do this by definition. Definition, like between logarithm and exponents. How do you convert this to exponential equation? This is a logarithmic equation. How do you convert it to exponential equation? So you now have that 2x minus 8 is equal to 5 exponent 4. That is what you have. So 2x minus 8 will be 5 times 5, 25, times 5, 125, times 5, 625, 625. So 2x will be equal to 625 plus 8. 8 plus 5 is 13. Carry 1. 8 plus 5, 13. Carry 1. 1 plus 2, 3. 633. So x will be 633 divided by 2. X will be 2 into 6 is 3. 2 into 3, 1, 2. Right? 1, 2. So 31 times 2 is 62. Okay, 62. Then 13. 2 into 13 is 6. 12. Right? 13 minus 12 is 1. 10, 5. 316.5. Okay, 316.5. 2 times 5 is 10, 0, 1. 2 times 6, 12 plus 1, 13, 3, 1. 2 times 1, 2 plus 1, 3. 2 times 3, 6. That's right. Okay. This is one way to do this. And you know, you can always check it. You can check it. How do you check it? How do you check this problem now? You write your check. You write the equation. Log base 5 2x minus 8 is equal to 4. Left hand side, right hand side. So this is 4. This is log 2x minus 8 base 5. Right? So this will be log base 5 2 times 316.5 minus 8. So this is log to base 5. This will be 633 minus 8. Okay? So this is log to base 5 of 625. Which is what? Log 5 to the exponent 4 base 5. Right? Which is now 4 log 5 base 5. And then from the law of logarithm, this is 4 times 1, which is 4. 4 on your left, 4 on your right. You can jump up and touch the ceiling. Yeah. This is the way to check it. Another way, do you want me to teach you another way you can do this? Let me just show it to you. How about it? Let me show it to you, and you know, another way you can do this is this. You can have it like this. Log 2x minus 8 base 5 equal to 4. So what you might want to do is this. You can change this. You can change this to logarithm to base 5. Right? I did it in the previous videos I've done. I did it. So how will you change this to base 5? This means log base 5 raised to the power 4. Change that. Because this is 4 log 5 base 5. You know, log 5 base 5 is 1. Okay? So that's the way you can change it. So here, and once you do this, you can now cancel log. You know, cancel log base 5. And cancel it, so you will now have that 2x minus 8 is 5 raised to the power 4. This is second way. Second way to do it. Yeah, you can always make, you know, any number, you can change it to log right away. Like if I have 32 and I want this to be in log 4. So this will be log base 4 raised to the power 32. If I want it to be log base 4, it will just be log base 4 raised to the power 32. If I have 7 and I want it to be in base 10, so what will it be? It will be log base 10 raised to the power 7. That's it. That's the way you do it. Okay? That should be 10 million, right? 10 million. Yeah, if you do log 10 million, it should give you 7. Okay, now, question 3. Let's do question 3. Question 3, we have log x plus 12 to base 5 plus log x minus 12 to base 5 equal to 2. So you can do this, you know, you can do it two ways. But let's do it by definition. Let's do it by law and by definition. So by law of logarithms, you know that log a plus log b is equal to log ab. Law of logarithms, right? Log a, you know that log a plus log b, and this is in base 10, is equal to log ab, and vice versa. Okay, vice versa. Log ab is equal to log a plus log b. right? To any base at all. So this is what? Log to base 5. This is, you could have a bracket here. X plus 12 times x minus 12, okay, equal to 2. And then you can do this by definition of log. That is, convert the logarithms to exponents. What do you have? You now have that, and we could just write this in parentheses. X plus 12 times x minus 12 is equal to 5 squared. 5 raised to exponent 2. This is difference of two squares. If you want to expand it, that's fine. But I would prefer to write it x squared minus 12 squared is 5 squared. So x squared minus 144 is 25. That means that x squared is 25 plus 144. So x squared is 169. And then what do we do from here? We use the square root property. Square root property. Okay? Let's use the square root property. And if we do that, we now have that x will be plus minus square root of 169. You need to view my videos on that. Right? So x will be plus or minus 13. X is plus or minus 13. What do we do next? Let's check it. Okay, let's see which one is, whether the two roots are the actual roots or whether we have any extraneous roots. We check it. And how do we check it? We write the equation. So we go ahead, in the check, we write the equation log base 5 x plus 12 plus log base 5 x minus 12 equal to 2. Left hand side, right hand side. Right hand side is 2. So left hand side is log x plus 12 base 5 plus log x minus 12 base 5. Okay, let's check first for x equal to 13. Let's check for x equal to 13, right? So if we do that, what do we have? We have log 13 plus 12 base 5 plus log 13 minus 12 base 5. Okay, so what do we do? Let's see. So this will be what now? Log what? Log 25 base 5 plus log 1 base 5. You see that? Log 25 base 5 plus log 1 base 5. So this is log 5 squared base 5 plus, log 1 to any base is 0. Log 1 to any base is 0. But if you don't want to put 0, if you want me to prove it, I'll prove it. This is log 5 raised to power 0 base 5. Because anything to exponent 0 is 1. So this is 2 log 5 base 5 plus 0 log 5 base 5. So this is 2 times 1 plus 0 times 1. 2 plus 0, and that is 2. 2 on your left, 2 on your right. So 13 works. 13 works, right? Now let's check for negative 13, okay? But meanwhile, you can do some let's move campaign. Let's move. Let's keep fit because we got it right. At least we got one solution right. Okay, now let's check for x equal to negative 13. See what we got. X equal to negative 13. This will be what now? Log base 5 negative 13 plus 12. Oh no, this won't work. Plus log base 5 negative 13 minus 12. Okay. Now this will not work. Log to base 5 negative 1 plus log to base 5 negative 25. No. You can't have log of a negative number. No, it will give you an error. Yeah, so this is no. Okay, so the answer is x is 13. Right? Question. We have 9.6 exponent 3x equal to 95. So if we look at this now, 95 is not a multiple. 95 is not a multiple of 9.6. It is not. It is not a multiple of 9.6. So it will be difficult for us to just solve this exponential equation just like that. So what do we have to do? We have to introduce log to both sides. So that we can solve it. And once we do that, we now have that log 9.6 exponent 3x equal to log 95. Right? This will now be what? 3x log 9.6 equal to log 95. Then you divide both sides by log 9.6. Okay? And you have 3x equal to log 95 divided by log 9.6. And then you can multiply both sides by 1 over 3. You can multiply both sides by 1 over 3. Now, they usually ask you to round this to some decimal places. So, in this case, let's say, I don't know how many decimal places they asked you on the quiz. But let's say round answer to 4 decimal places. Let's say round answer to 4 decimal places. Please, you have to do the one they asked you on the quiz. So, you can multiply both sides by 1 over 3. You can multiply both sides by 1 over 3 so that you can isolate x. And if you do that, okay, x will be log 95 over log 9.6 times 1 over 3. So this is like saying that this is log 95 over 3 times log 9.6. Okay, so I'm going to use my calculator to do this. You have log 9.6 times 3. Now some calculators you can easily do that. You can just do 3 log 9.6 and it gives you the answer. Some calculators you have to put 3 times. Some calculators you can just put this right away and it will give you the answer. But you have to put parentheses here. Some calculators, if you're using it, if you're putting this, you might need to put parentheses. If you're just putting it like that in the calculator. Otherwise, just do it one at a time. In fact, I will encourage you to do it one at a time. First of all, do 3 times log 9.6, keep your answer. Then do log 95, keep your answer, and then you divide. You divide what you got here by what you got here. Okay? You divide your answer here by your answer. Your answer at the numerator divided by your answer at the denominator. Now I do log 95 equal to this. Okay? Divided by I'm gonna just shift answer. So 1.9777 23605 divided by 2.9468 13699 2.9468 13699 equal to this. So my x is 0.7 0.6711396.807. So if I have to round it, if I round it to the number 4 decimal places, I'll have 0.6711. Okay, to 4 dp, 4 decimal places, 4 dp, 0.6711. Okay, next thing is to do what? Check. If we're checking, we won't round it. We're not going to round the answer, no. So we are going to use our answer like that. Because, you know, I like to check. Left hand side, right hand side. Right hand side is 95. Left hand side 9.6 exponent 3x. So I'm going to use that, the x there. X is 0.6711396.807. So I'm gonna do 9.6 raised to power 3 times 0.6711396.807. So this is times 3 equal to this. So this is 9.6 raised to power 2.013419042. Okay, so I will do 9.6 raised to power answer. Okay, so I have 94.9999 1 2 3 4 5 6 7 1 2 3 4 5 6 7 1 2 3 4 5 6 7 1 2 3 4 5 6 7 5, which is approximately 95. Okay, so we got it right. And then we can eat some spinach. You know, we don't want to eat pancake. We want to eat spinach to be healthy. Okay, so let's do the next question. Let's do the next question, folks. Okay. Question 5. Question 5, it says, write this in a single log. Find log of this. Log 243 to base 1 over 3. Log 243 to 1 over 3 as base. I have 2 methods to do this problem. 2 methods, 2 ways to do it. Do you want to learn the 2 ways? Okay. First way, by definition. Okay, first way I call it by definition of logarithm. By definition, convert log and exponents. Log and exponents. So you just say let log 243 to base 1 over 3. Let it be something like x. X. Let it be x. Now this is not an equation, but I've made it to a logarithmic equation. You know, but this is not an equation, so I'm not gonna check this. But you can check, you know, there are some calculators. If you have a TI Inspire. Okay, they did not pay me to market them. I am not their marketing person or salesperson. I'm not. But I'm just telling you, if you have TI Inspire, and there are some calculators on my website. There are some logarithmic calculators on my website. You can just put in this like this. It gives you the answer. Yeah. Now, remember this is a fraction, so be careful. Yeah. You can do that also in TI Inspire. So, but let's solve it. It's of no use. Let's solve it. Okay. I want to put this to be equal to x, then the relationship between exponents and logarithms, I would have 1 over 3 exponent x equal to what? 243. And now this 1 over 3, you know that 1 over 3 means what? 3 raised to power what? Negative 1 times exponent x equal to 243 is what? 3 raised to power what? 3 times 3, 9, times 3, 27, times 3, 81, times 3, 243. 3 raised to power 5. 3 raised to power 5. Or we can do, let's do fifth root of 243 and see what it gives us. Fifth root. Fifth root of 243. 5 shift x root 243. Yeah, it gives us 3. Yeah. So now we can finish this stuff. Well, what do we have now? We will now have what? That 3 raised to power negative x is equal to 3 raised to power 5. So they have the same base. They have the same base, so equate their exponents. We now have that negative x is 5. So divide both sides by negative 1. Divide both sides by negative 1. X is negative 5. Okay? X is negative 5. So this is equal to negative 5. Now, because this is not an equation, you don't need to check it. I mean, I'm not going to check it because I had to make it an equation though. Yeah. Now, but this is one way. This is first way of doing it. Now, let's do it second way. We can do it second way. Second way of doing it. By law of logarithm. By law, change of base. You can call it by law or change of base. Change of base. Change of base of log. So we have log 243 base 1 over 3. Let's change this to base 3. Let's change it to base 3. It is better we change it to base 3. Okay? So if we change it to base 3, this will be log 243 base 3 all over log 1 over 3 base 3. Right? All over log 1 over 3 base 3. Okay? I will have to erase this so that I will finish up from here. So what would this give me? What would this give me? This will give me log 3 raised to power 5 base 3 over log 3 raised to power negative 1 base 3. You see that? By log. So this will be 5 log 3 base 3 over negative 1 log 3 base 3. And of course by law we know that log a base a is 1. Okay, so this is 5 times 1 over negative 1 times 1, which is 5 over negative 1, which is negative 5. That is the second way you can do it. Second way you can do it. Okay? That is it. Now, question 6. Write as a single log. We want to write this as a single log. This question right here. We want to write it as a single logarithm. So what do we have? We will have what? Log base p t cube. T cube. Okay, this is log base p t cube. This is, I've done videos on this. We've done the videos on the playlist on logarithms. Then plus, this is log x, log base p, x raised to power 1 over 2, minus log base p, z raised to power 3 over 2. 3 raised to exponent 3 over 2. Then minus log base p a cube. You see that? So what will this give us, folks? What will it give us? We have from the law of, you remember the law of logarithms, okay? This is log to base p t cube times x raised to power 1 over 2 divided by 0 raised to power 3 over 2 divided by a cube. I'm going to do this one at a time. From the law of logarithms. Okay? Law of logarithms. So what would this give me? What is it going to give me now? We will now have log to base p. We'll do it one at a time. This means t cube x 1 over 2 times 1 over z 3 over 2 times 1 over a cube. You see that? Okay, so this will now give me log to base p, and it will be t cube x 1 over 2 divided by a cube z 3 over 2. Or you can put z 3 over 2 a cube. Whichever way you want to do it, that's fine. That's fine. But you know, I just put this because t comes before x and a comes before z. So this becomes your answer. Okay? Alright, next one. Next one is question 7. Question 7. Convert 450 degree to radians. Now remember, in the videos I did, we know that pi radians is what? 180 degrees. Pi radians is 180 degrees. So 180, I mean, you can establish this as a proportion. You can establish it as a proportion. Okay? You can write radians degree. This is pi, this is 180. So 450 will be here, 450, and then x. You can put x. You want to find x. You want to leave your answer in pi. Then you can just establish it as a proportion. We see that pi over x is equal to, you can just write it as x over, because it will be easier for us this way. X over pi equal to 450 over 180. This is one way to write it as a proportion. One way to write it as a proportion. Another way to write it as a proportion, you can have x over 450 equal to pi over 180. Okay. Another way, you can write 450 over x. 450 over x equal to 180 over pi. Another way to write it as a proportion, pi over x equal to 180 over 450. So when it comes to conversions, you can always establish it as a proportion. And you write it. Now I'm going to use this one because it's easier. I'm going to use this one. So x will be pi times 450 all over 180. So this 0 cancels 0. X will be 3 can go into 18, right? Or 9. 9 can go into 18 to give you 2. 9 go into 45 to give you 5. So x will be what? 5 pi over 2 degrees. 5 pi over 2 degrees. I mean radians. Don't mind me. Some dumb. 5 pi over 2 radians. radians. That's the answer, 5 pi over 2 radians. Okay, next one, question 8. We are getting there. Question 8. 8. We have find the length of arc. So given that the central angle is alpha, which is pi over 5 radians, and r is 25 inches. So we see that the length of an arc L is, if it's degree, okay, if the angle in degrees, we have that L is theta over 360 times 2 pi r. Okay, that's the length of an arc. L is the length of an arc. But if angle in radians, we see that L is theta over 360 is what? 2 pi. Because pi is 180. So 2 pi is 360 times 2 pi r. This is what we need here. Theta over 360 and theta over 2 pi times 2 pi r. Because our angle is in radians. The central angle is in radians. So this is what we need. Now L will now be, in this case, alpha. You can put alpha, okay, since they used alpha. Now here, theta is central angle. Here, alpha is central angle. That is angle at the center. Okay, that's the central angle. Then we now have to substitute this 5 over 5, right, divided by 2 pi times 2 pi r. 5 over 5 divided by 2 pi times 2 pi r. We can go ahead and divide this right away. We can do that, so we don't, So L will be 5 over 5 times r. R is what? R is 25. 25. Okay? So 5 into 5, 1. 5 into 25, 5. So L will be what? 5 pi. 5 pi what? Inches. 5 pi inches. That's that. Okay? 5 pi inches. Comprende? Comprende? Comprenez-vous? Okay. Now, the next one is question 9. Question 9. Question 9 deals with coterminal angles. Please, you need to view my videos on that. And you view my videos also on this, length of an arc. Alright, coterminal, find a positive coterminal angle and a negative coterminal angle of this, the angle 88 degrees. A is 88 degrees. So now you know that alpha and beta are coterminal angles if alpha and beta are coterminal angles if beta is equal to alpha plus 360 K. 360 degree times K. Okay, 360 degree times K. Where K is an integer. Where K is an integer. It could be positive or negative integer. Okay? It could be, K could be 1 or negative 1. K is an integer. Alright, now if you want to find a positive coterminal angle, we have that, of course, in this case, where we say where k is an integer, you don't want to put k to be 0 because it's gonna be like beta equal to alpha. You don't want to do that, no. Where k is an integer, the integer I mean here is like k to be 1, k to be 2, k to be 3, okay? Or k to be negative 1, k to be negative 2, k to be negative 3. That is the integers I mean here. Okay? 1, 2, 3, 4, 5, 6, or negative 1, negative 2, negative 3, negative 4. So they just want us to find a positive coterminal angle, so just one. Okay? So what we do is we just put, in this case, alpha. Okay, this means like your alpha, 8 degrees. So beta, in this case, let's do k to be 1. K to be 1, positive coterminal angle. Let k be 1. Let k be 1. Because that's the first one. So this will be 88 plus 360 times what? 1. So beta will be 88 plus 360, which gives you what? I like doing this way. This is 8 and this is 14. This is 4. Okay? So 4 for the 8. 4 for the 8 degrees. That is your positive coterminal angle. Now negative coterminal angle, what do we do now? We let k to be what? Coterminal angle. We let k to be negative 1. Okay? So beta will be what now? Beta will be 88 plus 360 times what? Negative 1. 360 times negative 1. Whether you use times like this or you put it like this, it's the same thing, okay? It's the same thing. So this is negative what? Negative what? We can go ahead and subtract this. 10 minus 8 is 2. 15 minus 8. 10 minus 8 is what? 2. This is 5. 15 minus 8 is 7. Negative 272 degrees. Okay? Okay? That's it. Now, last but not the least, question 10. For this part 1, we will still do part 2. What we got for question 10. Now, if they wanted more, assuming they wanted more, if they say two coterminal angles, you do k equal to 2. You find 360 times 2, then plus 88. You keep finding it that way. If they wanted negative coterminal angles, you do k equal to negative 2. If they wanted 2 negative coterminal angles. So that's the way you keep doing it. That's it. Question 10. We have that A is equal to 800 E raised to exponent negative 0.003 T. 0.003 T. Okay. Find A at T equal to 0. At T equal to 0, our A will be 800 times E negative 0.003 times 0. Right? So A will be 800 times E raised to power 0. And anything raised to power 0 is what? 1. Anything raised to exponent 0 is 1. So A will be 800. Did they give us the unit? Okay, they didn't give us the unit. A will be 800. Okay, at T equal to 0. Now let's go ahead and find it. Let's find it at T equal to 100. At T equal to 100. And see what we got. At T equal to 100, we have A to be 800 E times E negative 0.003 times what? 100. So A will be 800 times E This is a 1, 2. Negative 0.12. Negative 0.3. Okay? So A will be 800 times. Okay, we now have the, I have to use my calculator here. E raised to power negative 0.3. Let's see here. In your calculator you have it. In your calculator you have it as e raised to power x. Okay. So I better do shift e raised to power negative 0.3. Okay, this is what it gave me here. 0.74081 74081.82207. Then times 800 times 800, and that is 592.6545.765. And they might ask you to convert it. Okay? They might ask you to convert it to decimal places. Let's say, assuming they ask you to convert it to 100, 100th. Convert to the nearest 100th. Okay, convert to nearest, convert to nearest 100th means 2 decimal places. Means 2 dp. 100th. TH. They taught us. They taught us as when I was the little child to pronounce TH with the tongue. 100th. The 100th. TH. So it will now be 592.65. And that becomes your answer. Okay? Alrighty. So please, thank you so much for listening to this video presentation. Watch out for part 2. And you have a great day.